If you look closely at your smartphone screen, it turns out we are once again stuck in that annoying corner of digital reality that tech giants love so much. I'm talking about the situation where storage space is almost full, and you shouldn't be afraid of this notification because your data is about to vanish. No, you should be afraid because the corporations of good believe we have way too much extra cash lying around for monthly subscriptions, and technically, they're right. We've been paying for thin air for years. To save you from those monthly payments, I want to share a guide on assembling the ultimate personal cloud. We'll see how to make old hardware and Nextcloud work faster and more reliably than paid alternatives. We'll figure out why an old laptop beats the hyped up Raspberry Pi with one hand tied behind its back and what a built-in UPS has to do with it. We'll find out how to punch through any NAT and access your files even from a bunker using Tailscale. And finally, we'll ask the question, why pay for someone else's cloud when your files can live at your house, flying automatically from your iPhone straight to your hard drive? Brew some tea, dig out your Necro books, and let's start building our own internet. For those impatient to start installing, skip ahead using the timecodes. In the meantime, I'll explain why this solution is the best bang for your buck and how to adapt it to your specific needs. So, meet our heroes for today. On one side, a battle-hardened veteran of office wars, a laptop running on something like a 4th generation Intel core. On the other side, a standard external hard drive that you probably bought 5 years ago for backups and forgot about. And while the members of the cult of NVMe are twirling their fingers at their temples, let's face the truth. We don't need NASA speeds for a home cloud. Syncing your photos from your phone isn't the same as launching Cyberpunk 2077 on ultra settings. There's no crazy random reading of tiny files here. It's just sequential writing of large blocks of data. For your old processor, this is a walk in the park. The only thing that will put a load on it is traffic encryption. But for a CPU from 10 years ago, that's a second grade math problem. The best part here is the price. If you don't have your own old laptop, you can go to a classified site and buy any Frankenstein for 40 to 50 bucks. We don't care if the screen works, if the keyboard sticks, or if it looks like it was used as a soccer ball. For storage, we're taking good old mechanical drives, a USB disk, or if you're a gourmet and found a laptop with ESA-TA, that's pure gold. You could, of course, plug in a regular USB stick, but honestly, trusting your data to a piece of cheap plastic that dies from overheating is a bad idea. Let's leave flash drives for carrying term papers. Of course, the scheme I'm going to show you is universal. Put it on a Raspberry Pi if you want, dig up Grandpa's desktop tower, or buy a fancy mini PC. The software is the same everywhere. But why am I rooting for the laptop? Because it's a server with a built-in UPS, damn it. Unlike a Raspberry Pi for which you need to buy power boards or a desktop that shuts down when the electrician down the street mixes up the phases, a laptop will simply switch to battery power. It will save your data, finish writing correctly, and won't even break a sweat. Plus, it's quiet, consumes electricity like a dieting supermodel, and has a ton of ports. Want to make a RAID array of 2 disks for reliability? Go ahead, there are enough ports. And when you get bored of just storing files, this same machine will easily handle a smart home, a torrent downloader, and a remote desktop. Anyway, the hardware is ready, the Frankenstein is assembled. Now let's breathe life into it and see how to make this pile of chips work for us, not for some guy in Silicon Valley. Let's move on to the software. So for our experiment, I decided to take the path of least resistance and humiliation. We are going to set all this up on standard home Windows 10, but don't rush to throw Rotten Tomatoes at your monitor console lovers. Actually, this is a Trojan horse. Under the hood, we'll have real Linux running via WSL, Windows Subsystem for Linux. I've already installed a clean system and drivers, and here awaits the first surprise from Bill Gates. If you, like most people, have Windows Home, the marketers have axed the built-in remote desktop, RDP for you, want RDP, pay for pro, but obviously we aren't going to pay. We install TeamViewer or Chrome Remote Desktop. This is actually better. They connect to the current session, so you see everything as if you're sitting in front of the laptop. Besides Windows itself, we will need the holy trinity of free software. Docker Desktop, the container ship for our software. Tailscale, the magic that will network us together. Nextcloud, essentially the brain of our cloud. The master plan is this. We proudly name our laptop with the disk the server. We install Docker on it. Inside Docker, like a Russian nesting doll, we stuff Nextcloud. And to reach this nesting doll from anywhere in the world, we cover the whole thing with a virtual Tailscale network. First things first, we go to pay our respects to the blue whale, download Docker Desktop from the official site, run the installer, click OK, next, I agree, I sold my soul. Wait for it to scatter its files across the system, and of course, it will demand a reboot. This is Windows, baby. You can't even change the mouse cursor without a reboot here. We're back on air. Launch Docker. Agree to their terms. Nobody reads them anyway. Skip all those joyful tutorials and surveys. We're here to do business, not make friends. And here, if your Windows is as fresh and innocent as mine, Docker will strike a pose. Master, update the WSL kernel. Well, if we must, we must. Copy the command, open the console with admin rights, feel like a hacker, paste it, and bam! A surprise from Redmond. The system throws an error and starts telling tall tales about how your processor is allegedly incompatible or virtualization is turned off. Don't fall for it. These are fairy tales for newbies. In reality, our build is just missing update packages. I installed the system from a flash drive I burned back in the Stone Age, so it's simply stale. Go to the update center and download everything Gates has prepared for us. Reboot. Again, yes. Open the console again, type the same command again, and miracle of miracles, this time everything goes as smooth as butter. Docker launches, the engine is humming. We are magnificent. Now let's prepare the soil for Nextcloud. So you don't break your fingers typing configs manually. I've prepared a ready-made spell file for you. The link is below in the secret KGB archive. Kidding, just in the description. Create a folder C:\nextcloud-docker right in the root. Keep it simple so we don't have to hunt for it in the system jungle later, and drop my file in there. Alright, let's peek under the hood. Inside the folder you downloaded, there are a few crucial moving parts. First, the application profile is set to Nextcloud manual. We do this so your server doesn't accidentally start updating or launching things when you're not looking. Control is everything here. Next up, the database credentials in the YAML file. For this demo, I left the password as strong password, which is about as secure as a screen door on a submarine. Obviously, change this to something real before you go live. You'll also notice the port forwarding is set to 8080. Why? Because it keeps Nextcloud out of the way, just in case you want to turn this old laptop into a smart home hub later. No port conflicts, no headaches, but the real MVP here is the mount-run.bat file. Because we are using Windows, we have to deal with Windows limitations, specifically Docker's inability to automatically grab an external USB drive. This batch script is our digital duct tape. It forces the Windows subsystem for Linux to mount your external drive so Docker can actually see it. Step 1. The Tailscale magic and drive prep. Before we even touch the container, we need our secure personal internet. Enter Tailscale. I've already downloaded the installer, and honestly, it's your classic next finish routine. Once it's installed, find the Tailscale icon down in your system tray, right-click and hit Login. You can use Google, Apple, or Microsoft to authenticate. Easy. We need this VPN IP address right out of the gate, so Nextcloud knows who it is from day one. While the VPN is spinning up, let's prep the physical hard drive. Two absolutely critical rules here. Format it as NTFS. We need to preserve file system permissions or Linux will throw a fit. Create a root folder. I just called mine data, and this is vital, remove the read-only flag in the folder properties. Step 2, firing up the server. Storage is prepped. VPN is up. Let's deploy. I'll show you exactly how my script works by dropping the commands straight into the console. First, we make a directory for the external drive inside WSL. Next, we mount the hard drive into that directory with specific metadata options. This ensures that when Linux writes a file, it actually owns it. Now for the main event, Docker Compose. Run this from the directory where you dropped the YAML config file. On my screen, the provisioning is flying because I already downloaded the images. If this is a fresh install, Docker needs to pull about 800 megabytes of data. If your Wi-Fi is powered by a hamster wheel, go grab another cup of tea and be patient. Once it downloads, Docker kicks off the container. Watch the logs for about a minute. The golden ticket you are looking for is the phrase Apache configured, resuming normal operations. Boom, we have a server. You can now log into the Nextcloud admin interface. By default, it's sitting at localhost /8080 in your browser. But wait, before we celebrate, we need a sanity check. Let's look at your external USB drive in Windows. Open that data folder. Do you see an index.html file in there? If yes, you are golden. Nextcloud is talking to the drive. If no, stop right here. The drive didn't mount properly. Do not pass. Go. Do not collect $200. Troubleshoot the mount before you do anything else. Step 3, the golden rule and final tweaks. If we're good to go, let's run through the initial Nextcloud web setup. It's already pre-filled with the data from our YAML file. Just verify the database user and host match, create a strong admin password, and let it do its thing. When it asks if you want to install a bunch of extra apps, skip it for now. We like our servers lean and mean. Now, we are in our own personal cloud, but there is one final crucial tweak. Right now, Nextcloud thinks its address is localhost. We need to tell it to use our secure Tailscale IP so we can access it from outside the house. Open Docker Desktop and go to the Volumes tab. Find the volume with config in the name and double-click it. Open config.php and find the line that says localhost. Replace localhost with your new Tailscale VPNIP address. Save, restart the container, and verify you can load the web page using that VPN address. Let's test it. Let's see if that brain surgery worked. Open up your server's new VPN IP in the browser and log in with your admin account. Right off the bat, you'll notice Nextcloud has already generated a few default test files for you. Peek at your external drive in Windows. Yep, they should be sitting right there. Now for a real-world test. We're going to take a folder from our laptop and upload it straight into the cloud using the web interface. For this demo, I'm just tossing in our config folder. Once the upload wraps up, let's go back to the external drive. Look inside your data folder, drill down into your username, and boom, there it is. Warning, listen to me carefully. Consider the files on this external drive read-only for you directly in Windows. Everything on this disk is now managed by Nextcloud. If you try to manually drag, drop, or delete files directly on the USB drive using Windows Explorer, Nextcloud will lose its mind, the database will desync, and you will be starting over from scratch. Put the drive behind the laptop and forget it exists physically. Step 4, the ecosystem, saying goodbye to subscriptions. Now for the fun part. Let's make the magic happen across all your devices. The Windows client. I've spun up a Windows Home VM to simulate your daily driver PC, install Tailscale, log in, download the Nextcloud desktop sync client. Log in using your Tailscale VPN IP and your Nextcloud credentials. Pick a folder on your desktop to sync. Just like that, the files we uploaded earlier appear on the laptop. Let's create a new folder and a text file here. Check the server. Bam, it's instantly on the external drive. Client 1 is operational. The Ubuntu client, same logic, but with that sweet Linux efficiency. Pop open the terminal, apt install Tailscale, run Tailscale up, click the link to authenticate. Next, apt install Nextcloud desktop. Open the app, punch in your VPN IP, pick a sync folder, and wait a second. All the files from the Windows machine are sitting right here on Ubuntu. I'll make a quick LibreOffice document here. And instantly, it's back on the server and synced to Windows. Seamless. The iPhone, iCloud killer. Time to cut some costs. Download the Tailscale and Nextcloud apps from the App Store. Log into the VPN, then log into Nextcloud using your VPN IP. We can immediately see our synced documents. You can edit them right here on the phone. But here is the holy grail, photo sync. Let's snap a few random photos, go into the Nextcloud app settings, enable automatic media upload, and point it to your camera roll. In seconds, Nextcloud scoops up those new photos and fires them directly onto the hard drive sitting in your closet. And just like that, we are done. You have a fully operational private multi-platform cloud running on junk hardware, securely accessible from anywhere. In the next guide, I'm going to show you how to build this exact same setup purely on Linux, which is faster, infinitely more flexible, and drops the Windows overhead entirely.